Hi, welcome back to NPA Teaching. In this video, we are going to discuss the methods to find the limits, namely direct substitution method or plugging in the x value, factorization method and rationalization method. The first technique for algebraically solving a limit is a direct substitution method, or to plug the number that x is approaching into a function. If by direct substitution of a point in the given function we get a finite number, then that finite number is the limit of a given function. If you get an undefined value, that means 0 in the denominator, then you must move on the another technique. But if your function is continuous at that x value, then you will get a value. If f of x is polynomial, rational or trigonometric function, this direct substitution method is used to find the limit of a function. You can use other methods only when this method fails. Let us take the first method for solving the limit, that is direct substitution method. For example, evaluate limit x square minus 3x plus 4 where x approaches to 2. So as per sum or difference rule of limit, which is discussed in the previous section, it can be write as by taking the limit of individual parts and then put them back together with appropriate sign. So it will become the limit x square where x approaches to minus limit 3x where x approaches to 2 plus limit 4 where x approaches to 2. So if you substituting the value of x is equal to 2 on this limit, then it will become 2 square minus 3 into 2 plus 4, which is equal to 2. So this is the direct substitution method to find the value of limit, that is plugging the number or the value of x which is approaching into a function. If you get an undefined value, then you must move on the another technique. The second method to find limit is factorization method. In limit f of x where x approaches to a, after putting x is equal to a, attain a form of 0 by 0 or a form in which denominator is 0. Then factorization method is used to find the limit of a function. Finding a limit by factoring is a technique to find the limit that work out by cancelling the common factors. For example, evaluate limit x square minus 4 divided by x minus 2 where x approaches to 2. If we plug in x is equal to 2 in the given function, then we will get 0 by 0, which is undefined or it is indeterminate number. Then how do we find the value of limit in the indeterminate form? Limits that end in the form of 0 by 0 usually can be solved by factoring the numerator and denominator. Then find the common divisor and divide both the numerator and denominator by it. For example, here the x square minus 4 can be write by using its factors, that is the factors of x square minus 4 is equal to x minus 2 and x plus 2. So we can write it as limit x minus 2 into x plus 2 where x approaches to 2 divided by the limit x minus 2 where x approaches to 2. So here x minus 2 and x minus 2 will be cancelled. Then limit x plus 2 where x approaches to 2. So here we are putting x is equal to 2, then it will become 2 plus 2 which is equal to 4. So this is the factorization method. The third method of finding the limit is rationalization method. If a function involving the radicals, that means radical function is a function that contains the variable inside a root. So rationalization of numerator and denominator may help to evaluate the limit of a function. For example, evaluate the limit root a plus x minus root a divided by x where x approaches to a. So we begin by substituting x is equal to 0 into the function to see if it will be undefined or not. So if you substitute here x is equal to 0, then we will get a 0 by 0 which is undefined or it is an indeterminate number. So we also notice that there is no obvious factorization we could perform to eliminate this problem. Therefore, we use the trick called rationalizing to get around this issue. Rationalizing the technique for evaluating the limit is based on the multiplication by convenient form of 1. We multiply the numerator and denominator by conjugate of the numerator in this case. The conjugate of a plus b is the a minus b. So similarly, the conjugate of a plus root a plus x minus root a is the root a plus x plus root a. Then we multiply the numerator and denominator by using the conjugate. So it will become the limit root a plus x minus root a divided by x into root a plus x plus root a divided by root a plus x plus root a, where x approaches to 0. So here root a plus x into root a plus x, which is equal to a plus x, and minus root a into plus root a, it will become minus a, divided by x into root a plus x plus root a. Here the plus a minus a will be cancelled. Then here it will be remain x divided by x into root a plus x plus root a. Then here in numerator and denominator there is a x. So x and cancelled. So it will be 1 by root a plus x plus root a. Then if you substitute x is equal to 0, then it will become 1 by root a plus x. That means here 0 plus root a. So we can write it as a 1 by root a plus root a, which is equal to 1 by 2 root a. I hope you are clear about the methods to find the limit, that is direct substitution method, factorization method and rationalization method. So the direct substitution method is the common method for using to find the limit, but if you get an undefined value by direct substituting, then you can go for considering the factorization method and rationalization method. Have a nice day and see you in the next video. Thank you.